So we're going to do round two with Matt and Dugan and some Openshift goodness here. So it's all you, Matt.
Cool. Have any Openshift gimmies today?
I know.
We need some swag. We got falling down on the falling down.
Yeah, I know.
We'll work on that for next one.
I actually asked Michelle that's at Openshift marketing. I don't know her, Werner. She's out west.
Yeah.
I asked her for some of those USB, bottle openers. Those things are pretty
Sweet.
Those are real sweet. I guess they're hard to get a hold of.
Yeah, that's why you gotta rate it when you're at something. You gotta try to rate the booth. Matt, I'm not threatening to walk out on you. I'm just standing.
That's all right.
Not that you were worried in the first place.
Cool. All right, so Matt Dugan, I work for Shadowsoft. I do middleware and cloud architecture. Work to support the sales team, support Red Hat sales reps as well. Go out to client sites and help them talk through their business problem, find out where Red Hat technologies fit into their solution, as well as some of the other stuff that we provide as a VAR. But we're going to talk a little bit about Openshift, which actually made a big splash a year ago at the Red Hat Summit, and as recently went GA. It's generally available for all audiences, safe for children in most cases. But basically what we're going to do tonight is we're just going to have a light, high-level stuff, kind of cover some concepts, and get a baseline around what you want to use cloud development patterns for yourself and in your enterprise, and why Openshift is a good selection for that. Then we'll do a quick demo with Openshift. So, no BS, what's cloud, right? We all have this thought when we're in IT and they say, well, we want cloud, what do you mean, right? Well, we want a portal, no you don't, you want content management, right? So no BS for cloud. So in real practical terms, this is how you're going to experience cloud in your organizations. You're going to find infrastructure as a service, platform as a service, software as a service. And these basically apply to 3 levels of application building. Acquiring the hardware and infrastructure that you need to run your stuff on, acquiring the frameworks, toolkits, libraries, and platforms that you need to run your application on, and finally running your application and providing value back to a user. So how does implementing on top of a platform as a service cloud change the way that you work? Well, basically, when you're building an app, not having the platform provided for you, you have the idea, you obtain the budget, you build your infrastructure, you configure and deploy it, then you enter your code test cycle, finally you launch, and then if you want to scale up later, you repeat. You build up a new instance, you make sure everything works, et cetera, et cetera. Now, on a platform as a service model like Openshift, especially where you have scaling built in, you immediately go from budget to build it to launch it. And while you're watching the scaling happen, you can have your beverage of choice. And the reason for that is that the platform decision is made for you. And so while you have control over the decisions that are implemented within the platform with something like Openshift or like a app engine kind of model or something like that, you have decisions as to how things are structured and configured. You don't have to go through the rigmarole of installing all that stuff and setting it all up and making sure the core of it works. And we'll get into some of that. So why Openshift? So if you were at Red Hat Summit, you probably recognize this picture on the left side of the slide here. Openshift is a bridge. So it combines technologies that are familiar with the enterprise with the agility that you want to have when you call something cloud. So why do you want it as a developer? Why do you want your organization to use it? Well, it's easier to sell in IT when you say it's built on Red Hat. It's good to have a big name there. It'd probably be even easier to sell if it was built by IBM, but then it wouldn't be good. It is 100% open source. It works on the cloud, and when we say cloud, we meant it was architected and built for the cloud. So when you go to Openshift Online, you're actually running on services that are provided by Amazon. It elastically scales, Elastic Compute Cloud, and it embeds the technologies that you want to use. So it's not just a Java JE container, not just another container, but it supports application stacks like Ruby or Python, Node, and any number that have been built from the community. Like you can go find cartridges that deal with Plone on top of Python, or Mongo, or MySQL, MariaDB, and you can build your own. Building a cartridge in OpenShift is actually pretty similar to architecting an RPM. It has very much a spec file-like feel to it, but you can build out a cartridge. So why really? So it's about shared responsibility. In the old model, you could call it the pre-cloud model, or you could call it the pre-DevOps model, or whatever you wanted to say. But the old model didn't really have shared responsibility. Operations, throw something over the wall. Okay, here's the hardware, it's yours. Fine. And then as a developer, you may find a problem with it. You're trying to configure stuff. Hey, this isn't quite set up right. Likewise, with applications being developed prior to hardware provisioning and operational environment being set up to be successful, you throw the application over the wall, and now the operations team has to deal with it. And pain ensues all around. So let's open it up. OpenShift really has 4 ways to interact with it. You have your developer and IDE tooling, so if you're using something like the JBoss Tools IDE, you have the IDE level integration with it. You have command line tools, which are written in Ruby. You download them as a Ruby gem. They're called RHC for Red Hat Cloud. You can interact it with your web browser. So when I was at Summit, they had a little booth outside and they said deploy your app on OpenShift, and I did it from my cell phone. So you really can do it totally via the web. And then there's RESTful APIs that connect back to the broker and allow you to manipulate the organization and operation of your apps on your nodes. So let's climb in a little bit more. So OpenShift Enterprise has really 3, and I say OpenShift Enterprise and Online are really the same thing. Online is tuned for the model that they're marketing it in, but it's really the same thing. So you have 3 basic concepts. You have these brokers. Brokers allow traffic to flow into nodes. Nodes are running cartridges, and the cartridges are what you use to compose your environment in which you're going to develop your application. There's a REST API into the broker there. It's all running on top of Realm. If you're running OpenShift Origin, which is the upstream community release, then you can run that on Fedora, you can run it on Arch Linux, anywhere you build a package or build it from source yourself. And you see the basic architecture that we see all the time, only now it's in a round container. And that is that these things stack up on top of each other. So you have your OS at the bottom, and finally you have your languages and frameworks at the top. So under the hood. Under the hood in OpenShift is an architecture that is designed to enable you to deliver HTTP-based services easily. So at the front of it, you have your proxy load balancer. So it uses HA proxy under the hood. It uses Apache with virtual host mappings that map to your application, what you consider your domain root to be. And when traffic comes in on HTTP or HTTPS, it comes in and says, oh, this is the URL I'm looking for. It balances across to a node which is running an instance of that, transparently forwards that traffic through, the application receives the traffic, and any cartridges that are part of that application that are composed in your platform can now activate and talk to each other within localized ports. So for example, if your application is running in JBoss and you have a Postgres database underneath, then Postgres is going to be running on maybe, it could be an ephemeral port internally, but your application is going to be able to connect to it and use it, even though you can't see Postgres from the outside world, you can only see your servlets. So the way this is controlled is from the operating system level. OpenShift, as it's currently implemented today, is taking advantage of control groups, file system quotas, SE Linux policies to make sure that things are only accessed in the way that they should be, and of course these namespaces. And all of this is so that you can empirically control the amount of resources that are being allocated to gears and are usable by gears, so the gears can't crosstalk on top of each other or inappropriately escalate their privileges within the system. The database underneath all of this is MongoDB.